So this question asks us about a mechanism and to say whether which one of the following is the correct mechanism. So we're doing a mechanism from a halogenoalkane. So the first thing I would double check is that actually all of these are 2-bromo-3-methylbutane, and all of the main organic compound is the same, therefore they're not trying to catch us out with that. It's all about the curly arrows. So we're trying to form but-2-ene, so that's important to pay attention to as well. That means our double bond, so we're going from 2-bromo-3-methyl, 2-bromo-3-methyl butane to but-2-ene with a 2-methyl group on. So we're trying to end up with our double bond between where the bromine is and where the methyl group is. That's quite important. So if we were to take a highlighter, we want to end up with the double bond here. So we want to end up with the double bond between these two carbons. So that's important about where the curly arrows go. Now if we look then at the first one, the first mechanism is a good mechanism. It's well drawn. The curly arrows are all correct, but it wouldn't form but-2-ene, it would form the but-1-ene because the proton being removed, the hydrogen being removed by the hydroxide ion in the first curly arrow step is from carbon number 1. So then we would have a look at the next one. The next one, the lone pair is going and collecting that hydrogen, acting as a base to pick up a proton, and then we're creating a double bond in the right place where we've highlighted where we would like the double bond, and we're losing the bromide ion. So it looks like B is correct. I'm going to select B, but I'm just going to double check down the others, see what's going on. In C, we're collecting a proton, but if you were to collect the hydrogen from the same carbon as the bromine, then this carbon would lose 2 atoms. This curly arrow here would create a C-. So this would create a very interesting species where we wouldn't have any double bonds and we've lost 2 things from the second carbon. And then D is a correct mechanism, but for the nucleophilic substitution, and would create us the alcohol, which is a possible thing to happen. So A, B and D are all possible mechanisms, but only B leads to 2-methyl but-2-ene.